Hi, good morning. The last thing that we were talking about here is this equation for current. We said I equals NQA times VD. I here it is the electric current in amperes, and N it is the number of free charges per unit volume, which is N equals uppercase N. This is the number. This one is the number of free electrons or free charges divided by the volume. A is the cross-sectional area, and usually if we have wires it's going to be pi r squared, and it is measured in meters squared. A Q it is the charge of the electron, which is the negative 1.6 10 to the negative 19 coulomb, and Vd is the drift velocity in meters per second. I'm gonna show you also how I will be able to solve one of the problems here. Let me bring this question in here. It's much gonna be meaningful for you. Then here I have this question. Calculate the drift velocity of electrons in a 12 gauge copper wire which has a diameter. What is needed here is just the diameter or the radius. Diameter of 2.053 millimeters, carrying a 20.0 ampere current. Given that there is one free electron per copper atom, and the density of copper is given as 8.8 10 to the 3 kilogram per cubic meters. Now here Vd is not known, diameter is given as 2.053 millimeter, I is 20 amperes, and this piece of information we're given, there is one free electron per one atom. And this is here, I want to remove that symbol here because later I will talk about something similar, and therefore I'm gonna write here density. Okay, we know that this is the equation, then Vd equals I divided by NQA. Beside what is given to you here, what is needed molar mass of copper, which is 63.54 gram per mole. I will set here an equation that is going to say N, how many electrons per atom, times this is Avogadro's number per mole, and 1 mole is 63.54 grams. This should be converted into kilograms, and then times the density. All right, and this is gonna give you this number, Avogadro's number. Okay, also I need to bring the other, this is the continuation of it. Okay, then here, that number here, this one is Avogadro's number. Density is in kilograms per cubic meter should be, and here I did say A equals pi r squared, which is the cross-sectional area. This is the radius, this is the diameter divided by the 2 to get the radius, and then from that you will be able to get the velocity, and it is in that direction because it is to the left because these are really electrons. They're gonna move against the electric field. All right, then this is an application of one of the equations that we use to calculate the current. The third one, it is related to a law that is very important in electricity. It is called Ohm's law, and that is talking about that I is directly proportional to voltage, and I is inversely proportional with the resistance. What does that mean? This means if you double V, the voltage R will go to 2I. If you triple V, then I is going to be 3 I's. On the other hand, if you double R, the current will drop to 1/2. If you triple R, I is going to go to 1/3. This is the meaning of direct proportional and inverse proportional. And finally, we can write this relation I equals V over R. It has so many forms. We can write it V equals IR. I can calculate R by V over I. Any form is accepted. These are all equivalent. Now I here, it is measured, is the current, it is measured in amperes, and V is the voltage measured in 4 volts, and R, it is the resistance in ohms. Here, this circuit, sorry, it is used to verify Ohm's law, and also at the same time we use it to calculate the value of the resistor. Here we have the resistor connected with a voltmeter, and we have an emitter in the circuit, and then we have a power supply that is going to change, and we have a switch, and then every time we are going to make to the power supply operating from 1 to 5 volts, and then every time we measure the current. We are going to find that here when we plot V versus I for a regular resistor that you find in the lab, we call this ohmic resistor, and it's going to be like, the graph is going to be a straight line. And the slope here equal rise over run and equals the value of R. Then this is how we determine the value of R. Here I have also more problems to apply the equation for I. Highly sensitive emitters can measure currents as small as 10.0 ampere. How many electrons per second flow through a wire with this type of current? Okay, this is from chapter 1. You know that FA, it's a prefix that equals 10 to the negative 15. We know that I equals Q over T, and therefore it is the number of electrons times the electronic charge divided by time, and then I need N, then it's going to be I times T divided by E, and from that I can get what is the number of electrons. For number 4, a television set connected to a 120 volt outlet consumes 21 watts of power. How much current flows through the television, and how much time does it take for 10 million electrons to pass through the TV? Okay, here, this is the power equals I times V and equals 21 watt. Then I can here calculate I as power divided by voltage, and that is going to be 0.175 amperes. And then for the current, I equals Q over T, and then the time is going to be Q divided by I. I have 10 million electrons, then it's going to be 10 to the 6, 10 times 10 to the 6, times the electronic charge divided by I, and that is going to be 9.14, 10 to the negative 12 seconds. And here, again, this is another prefix. This is really picoseconds. This is the same one, it is repeated. Also, this is one of the questions shows a plot of current versus voltage for two different materials, A and B. Which of these materials satisfies Ohm's law? And of course, the red one, since it is linear plot with a slope of 1 over r here. Why it's 1 over r, it's not r? Because we have the current on the y, and on the horizontal we have the voltage. If we flip like I did before, the slope is gonna be just r. Here also I'm gonna solve another one. I have a certain treatment procedure, includes 0.85 milliamperes of current that flows through a patient's brain when there is a 7.4 volt potential difference between the electrodes. What is the equivalent resistance between the electrodes? Here I summarize my value. V is 7.4 volts and I, it is 0.85 10 to the negative 3 amperes, and therefore R, it is V over I, and I can say it's gonna be 7.4 volts divided by 0.85 10 to the negative 3, and that is 8.7 10 to 3 ohms. All right, thank you for that, and see you soon in another video.